This tutorial will show how the various panel zone options within Etabs can affect the frame behavior. We will model three different frame options: centerline to centerline, rigid panel zones, and panel zones with deformations. We start with an 8-story, 3-bay by 3-bay building. A check of the load cases shows that we have 3. Dead with self-weight, live load, and a static earthquake load based on the UBC 97 in the X direction. Our first model will be with the centerline to centerline condition. We select all the model and go to the Assign, Frame, and Offsets command. The offsets will be determined from the actual beam column sizes, and make sure that the rigid zone factor is set to 0. When 0, this means that there is no rigid zone. We are now ready to run the analysis. We will switch the elevation view to show the deformed shape due to the static earthquake load. A right-click at a joint on the top level shows us the displacements, which for the X direction is 2.84 inches. Remember this number for comparison to the other frame displacements. Next, we will do an analysis with rigid panel zones. We unlock the model to remove the results of the centerline to centerline analysis and select the entire model. Go to the Assign, Frame, and Offsets command once again, but this time set the rigid zone factor equal to 1. Without any panel zone definitions, this will result in a rigid zone with no deformation. Rerun the analysis. Once again, display the earthquake deformed shape on the elevation view. A right-click on the top level shows that the lateral displacement has decreased to 2.3 inches from a displacement of 2.8 inches for the centerline model. Once again, unlock the model to remove the results of the rigid panel zone analysis. Our next model will include panel zone deformations, and we start by selecting the entire model. Check to make sure that the rigid zone offset is still set to 1. This ensures that the frame members are the correct length and that a centerline to centerline analysis will not be done. Select all once again, and this time go to the Assign, Joint Panel Zone command. In this model, we will use the elastic properties from the column for the panel zone, but we could also specify doubler plates or explicit values. The connectivity will be that for beam columns. Rerun the analysis. and view the earthquake deformed shape on the elevation view. A right click at the top level shows that the displacement has increased to 3.19 inches, approximately 12% more than the centerline model and 40% more than when the panel zone had no deformation. This concludes this tutorial.